In today's lesson, we're going to look at quadratic function concepts and review some of the things that we've learned about parabolas. Quadratic functions have some unique characteristics. Remember, this is what the shape of a quadratic function looks like. These are our parabolas. And there's a few things that we've learned along the way to be true about these functions. The first is that quadratics can open either upward or downward. If the leading coefficient for your quadratic is positive, or a is positive, then we know it's going to open upward. Where if a is negative, it will open down. Additionally, parabolas will always have a vertex, which is either the maximum value or the minimum value for the function. There's always going to be one y-intercept. And as we saw in the graphs, there could be 0, 1, or 2 x-intercepts. And lastly, every parabola is symmetric about a vertical line that passes through the vertex, and this is called the axis of symmetry. Now, quadratic functions can be written in one of three forms. The first and the most common is the standard form, which often is noted as ax squared plus bx plus c. Additionally, we can look at quadratics through what's called the factored form, where this has already been broken down into its two factors, a times x minus what we'll call r1 times x minus what we'll call r2, where r1 and r2 represent the roots, which also could be known as the zeros, or the x-intercepts, right? It demonstrates the factors for this quadratic. And lastly, it could be in vertex form, which is known as f of x equal to a times the quantity x minus h squared plus k, where hk is the location of the vertex. So as we look at the standard form, there's a few things that we can glean. The first is that the y-intercept is going to be the value of c every time. The axis of symmetry can be found by using the formula x equals negative b over 2a. And in order to find the vertex, we can then just plug that negative b over 2a value into our function to find the k, or the output at the vertex. In order to find the x-intercepts, we can simply solve the quadratic through factoring, complete the square, or the quadratic formula to figure out those roots. In the factored form, it's quite clear what the x-intercepts are right away. That's the r1 and the r2 values. The y-intercept can be found then by multiplying the a times the two roots, right? A times r1 times r2 will give you the y-intercept. And the axis of symmetry, because it splits the parabola in half, will be right in between the roots. So we can find the average of r1 and r2 and plug that in for x to find the output and our vertex. And in the vertex form, again, hk is the vertex, so that's delivered right away. The y-intercept then would be a times h squared plus k. The axis of symmetry will be at h, because it passes right through the x location of the vertex, and the roots can be found by solving the quadratic. Now, changing between these forms has some nice nuances to it, right? We learned about this. To go from standard form to factored form, well, we would factor the standard form. And in doing so, we would get the factored form. And to return back to the standard form, both from factored form and from vertex form, we can simply distribute and combine like terms, and we have returned to standard form. To go from standard form to vertex form, we learned a technique known as completing the square, which you can access in other MatHAMMatics video lessons. And you can transform your standard form into vertex form. To go from the vertex form into factored form, these are a lot less common, but they can be done for sure. The way that you would do this is to solve to find the zeros out of the vertex form. And then you can plug those zeros in as the two roots, keeping the same a value for your factored form. To change the factored form into vertex form, again, we can find where the vertex would be, right? Find the average of those roots, plug that value in, and then we would have our vertex, which can be reinserted to the vertex form, keeping the same value for a. So in future lessons, we will continue to dive into the specifics of these functions, but the hope is that this provides a nice overview for quadratic functions.